Hi, in this video we're going to look at types of chemical reactions. There are 5 types that we're going to talk about. The first type is synthesis, sometimes called combination. The second type is decomposition. There's single replacement, double replacement, and combustion. In this video, I just want you to be able to classify reactions as one of these 5. We're going to go into more detail into each of these reactions in separate videos. All right, so we're going to try to classify chemical reactions. So let's go ahead and start with our synthesis reactions. And just as the name implies, synthesis, we are making something from 2 other things. And it could be 2 or more things. So here, just a general formula, we have A plus X, and then they're going to come together to form AX. That's a synthesis reaction. So let's have a look at a few examples. Magnesium reacts with oxygen, these are our reactants, to produce magnesium oxide. Again, this is classified as synthesis. You have 2 things over here coming together to form one product. Let's have a look at what iron does in the presence of oxygen. It can form iron 2 oxide. The iron and the oxygen combine, they form iron 2 oxide. But under different conditions, iron can react with oxygen to form iron 3 oxide. And it just depends on the conditions around the reaction. This iron 2 oxide is a gray color. This one is more of a reddish brown color. So transition metals, sometimes they can form different products based on what conditions the reactions are done under. All right, well, it doesn't have to just always be reacting with oxygen. Here we've got sodium reacting with chlorine. Again, the 2 elements are coming together to form sodium chloride. It also doesn't have to be 2 elements combining. Here we have an ionic compound with water. So calcium oxide combines with water, and we see it forms one product, calcium hydroxide. We've combined them together, or we've synthesized them together. So you need to be able to classify these reactions as synthesis. So you're going to have 2 or more reactants combining into a single product. All right, well, decomposition, again, the name makes sense. You're going to have a single reactant that is going to decompose into 2 or more products. And so here is our general formula. AX is just going to fall apart into A plus X. Let's look at an example of this. Mercury 2 oxide, and oh my goodness, look at the triangle. That means it's heated, will produce mercury, and it's a liquid at room temperature, and oxygen gas. Again, you started with one thing, the mercury oxide, and then it's separated into 2 on our product side. It decomposed, it broke down. Here with water, you can apply electricity to it, and it can decompose into hydrogen and oxygen. Here we have calcium carbonate, and when you heat that up, you get calcium oxide and carbon dioxide gas. So to classify a decomposition reaction, notice that you're starting with one thing and it's decomposing into 2 or more products. Okay, now let's go on to single replacement. And single replacement is where one element replaces another element. So here we've got an A plus a BX. A comes in and boots out B and takes over B's place there. So it's now combined with X. Or we could have had a Y, so like a nonmetal, come in with a BX, and the nonmetal would replace the nonmetal, booting out the X and coming up with BY. What you notice here is that one element is taking the place of another. So it's basically just kicking the other one out. All right, so here we've got copper 2 chloride. It's a solution of pretty blue color. And we put some aluminum in it. So here we see aluminum is single. I say it's single, ready to mingle. So here it is, and it's like, oh, I want to combine with the chlorine. It comes in, kicks the copper out, and now aluminum is bonded to the chlorine. Okay, here we have magnesium, single by itself, and this is hydrochloric acid. And so a metal can also replace the hydrogen in the acid. So the metal comes in and says, okay, bye-bye hydrogen, and H2 gas is given off, and now the magnesium is combined with the chlorine to form magnesium chloride. we can also have a metal replacing a hydrogen from water. And that's what these alkali metals, they're fairly reactive metals that do this. So we have an alkali metal, potassium, single, ready to mingle, comes in and it replaces one of the hydrogens in the water, leaving behind a hydroxide. So the potassium is now with the hydroxide and hydrogen gas is given off. So we have a metal replacing a hydrogen from water. Here we have the halogen fluorine, and it's single, and it isn't going to replace the sodium. Sodium is a metal, so they're not the same. So we want it to replace something like itself, so it's going to replace the chlorine. So the fluorine comes in, boots the chlorine out, and we make sodium fluoride. So what I want you to notice in these single replacement reactions is that a metal will replace a metal, or a metal will replace a hydrogen from water or from an acid. The nonmetals are going to replace a nonmetal. Okay, we're going to have another video and we're going to do a lot of these reactions in class. We're going to also find out who can replace whom in something called an activity series. All right, so our last two types of chemical reactions are on this board, and one is double replacement, and here it is. Now in double replacement, basically what happens is they switch partners. So you've got like an AX, a metal, nonmetal, and BY, a metal and a nonmetal, and they just switch places. And so now the B is with the X and the A is with the Y. So I color-coded this one. I have our metals in green and our nonmetals in blue. So we had sodium sulfate, it was a solution, with barium nitrate, a solution. Those are our reactants. And then when we pour them together, we're going to have the barium replacing the sodium. So it's barium sulfate. And it just so happens that's not soluble. And so that would form a precipitate or a solid. And then the sodium went with the nitrate. So, and that is soluble, so that would be aqueous. So look at what happens there. We have two things, switching partners. I've seen an analogy of like dancers, like they're dancing with a partner, and then they switch partners. I think that's a good analogy. All right, the last type is combustion, and it just means that you're combining something with oxygen. And so we're going to have, this is propane, like a propane tank that you would use to grill hamburgers or something. In the presence of oxygen is going to form carbon dioxide and water. So for combustion, be on the lookout for oxygen as a reactant, but just because oxygen is a reactant doesn't mean it's combustion. What you should be seeing is that, see, this isn't a combination, it's a combustion, because you have this is called a hydrocarbon because it's got hydrogen and carbon burning essentially with oxygen to produce CO2 and water. Well, we're going to talk about each type of these reactions, all 5 types individually, and learn some more specifics about them. But right now, I hope that if I gave you a reaction, you would be able to classify it into one of these 5 types of chemical reactions.